This is homework problems for exercise 8.6 and exercise 8.7. The first question in exercise 8.7, question 4, if x equals 12 on t, find dx dt when t is 2. What you've always got to do when you don't have y's and x's, you've just got to make sure that everything is the right way around. Normally you would like to see this as y equals 12 over x, and then you would write, I know you can't see that, so normally you would see y equals 12 over x and you find dy dx. So we've got x is 12 over t, we're finding dx dt. It's always d something on this side, d whatever on that side. So it looks like this is the correct order. It doesn't need flipping around or anything like that. So the problem is the t, you cannot differentiate any powers of x or t when they're on the denominator. I've got to bring that t up to the top, up to the numerator. So how do I write it? 12 t to the minus 1. Okay. Right, so therefore dx dt is what? I keep the 12. Negative 1t. Negative 1 minus 1 is negative 2. So 12 times negative 1 is negative 12. T to the minus 2 is, you can put the t squared on the denominator. You okay with that? Girls, be careful here. 12 times negative 1, this is really negative 12t to the minus 2. But I want to write the t squared down the bottom. Because when you make the substitution, it's easier to substitute in. Girls, do you understand that that t to the minus 2 is on the bottom? So now we substitute. When t equals 2, dx dt is negative 12 over 2 squared, which is negative 12 over 4, negative 3. Because it's easy. All right. I think what's confused you there is the x's and the t's instead of the y's and the x's. So what you've got to do, you've got to look at that and say, well, that's just the same as it looking like this. Do you understand? And then I'm finding, so normally you would see it like this. This is what you like to see. You would like to see it as y equals 12 over x and find dy dx, right? Well, just look, the y has been replaced with the y has been replaced with the x, and the x has been replaced with the t. The y has been replaced with the x is replaced with the t, it's fine. Okay? That's why we make sure we do questions like this so that you don't get confused with the notation. But look, we'll be doing, this is differentiation. You end up doing it with trig functions, you end up doing it with exponential and log functions, you end up doing it again, first topic back next term. So you're going to get very used to this notation by the time, and we do it with some other applications of calculus. So you're going to be doing this for at least another term and a half using this notation. So you're going to get comfortable with it, all right? And you'll use it in 3 unit as well. So, okay, the next question, are we okay with that? The next question was question 6. Was this question 6 exercise 8.7 or 8.6?
This is 8.7.
But did you want 8.7 or 8.6?
I needed 8.7.
So someone else wanted 8.7, question 6?
Question 6 is
All right, in both of them? All right, we'll do exercise 8.7 first. Okay. The question is to find the gradient of the tangent to the curve y equals 3 over 2x squared at that point. Now, girls, you can't differentiate this with the x squared on the bottom. So keep the 3 where it is, keep the 2 where it is. You can only differentiate something like y equals x to the power of n. That's what you know how to differentiate. You don't know how to differentiate y equals 1 over x to the n. We don't want it written like that. So if it's written like that, you write it as x to the minus n. Do you get what I'm saying? So please don't move that 2 to the top. The 3 over 2, this really means 3 over 2 times 1 over x squared. Do you agree with me? See how 3 times 1 is 3 on the numerator, 2 times x squared is 2x squared on the denominator. So the constant is 3 over 2. Now how do I write 1 over x squared as x to the power of something? X to the negative 2. No, not to the half. It's x to the... 1 over means negative power, so it's x to the negative 2. So now I differentiate it. So that's what y is. So now, I know I'm running off screen. So now dy dx is, there's my constant, keep it there, 3 over 2 times You bring the negative 2 to the front, write down the x. Please, girls, you know how many people would write negative 1 as the power now? It's negative 2 minus 1. You've got to say it to yourself. Negative 2 minus 1 is negative 3. Now, let's rewrite that.
I thought the constant is 0.
There's no constant.
3 over 2.
No, that's... But if I was asking you to differentiate 2x to the power of 4, what would you do?
4 times 2x.
Yeah, so why? This is just because it's a fraction, it's not on its own. It's multiplied by that. So when terms are multiplied, they're stuck together. You sure you get that? This is not like plus 3 on 2 at the end. That's just like, so why don't you drop this 2 here? Why don't you differentiate that 2 to be 0? That's the same as 2/3. Like, just because it's a fraction, girls, don't get, if I had 2/3 x to the 4, would you drop this 2/3? So why, you're dropping this because you've got a negative power. But it's not split. When things are multiplied together, they're not split. It's the same term. So I can't say that 2 times 3 is split. 2 times 3 is not 2 plus 3. They're not split. Girls, Georgia?
Yeah.
2 times 3, is that the same as 2 plus 3? That's stuck together. That's 6. So if things are attached to something else with the multiplication symbol, they're the one term. But I've just split it by putting a times. It's actually the one term. So that's your constant. Like it's the coefficient of your x. It's not a constant on its own. All right, girls, it's important that we get that. So I'm cancelling out the 2's here. Are we okay with that? And what do we get? Negative 3. I'm going to write that x to the minus 3 next to it. Now I'm going to rewrite the way that looks. I don't want x to the negative 3 on the numerator, so I put it over x cubed. Girls, are we okay with this? With our negative powers? So that's what dy dx is. So now I just want the gradient of the tangent to that curve at the point x is 1, sorry, at the point 1, 1.5. Which value do I substitute in? Don't you substitute the x value in? So when x is 1, the gradient is negative 3 over 1 cubed. Negative 3. Now, what's this y point here for? What would that help me with? The equation. So girls, that point, they're just asking for the gradient of the tangent to the curve. If I wanted the equation of the tangent, what would I do? If I now wanted, yeah, I'd use point gradient formula. So girls, sometimes they'll give you the x value and then sometimes they'll give you the xy value. You only need, sorry, I'll just come back here. You only need the x value for the gradient of the tangent, but you need the x and y value for the, you only need the x value for the gradient, but you need the xy value to do the equation of the tangent.
If they were asking for the gradient of the normal, would it be 1/3?
Yes, if they, now girls, yep, okay girls, why don't we just do that here as an extra part of the question? What's the gradient of the normal to the curve? So what's the gradient of the normal? So I'm going to go, therefore, the gradient of the tangent, girls, at x equals 1 is negative 3. And if I asked you as well, what's the gradient of the normal? It is just 1/3. That one's negative 3, which means negative 3 over 1. You flip it, you get a third, and if one's negative, the other one's positive. So the gradient of the normal, if I did ask you, would be a third. So then from here, you could find the equation of the tangent if you wanted, or the equation of the normal if you wanted. Okay? Which other questions, girls? In this exercise? All right. No, I will get it. I can put it up on the... No, it's all right. Wait a sec. Okay. All that work we did on sketching working out gradients. So gradient of tangent is to differentiate. Now, the problem is you've got to make this look nice. So function of x is root x on 2. You don't know how to do root x. You only know how to differentiate x to the power of n. So I don't want that written as root x. How do you write it? X to the what? X to the half. Now, this 2's on the bottom, it's just a constant. I can write that as a half x to the half. You okay with that? Or you differentiate, but just keep the 2 there. Don't get rid of that 2. It really is a half times x to the half. So f dashed x. Do you get that, girls? I actually would just keep that there, and when you, all right, be careful. So you've got a half is your coefficient times. What do you do with that half? Don't you, if you're differentiating x to the n, what do? Don't you bring the n to the front, write down the x and subtract 1 from the power? That's the rule. So you, just because it's a half doesn't mean the rule changes. This is the half from the coefficient. Now what do I do with this x to the half? Bring the half to the front, write down the x. I'm just bringing the power down to the front, writing down the x, and then what am I doing to the power? Subtracting 1, which means negative a half. So now multiply these. This is all multiplied. So you get a quarter, and this x to the half, can I just write it on top? X to the negative a half. I'll write that again. So girls, I've got a quarter, haven't I? And where's this x to the negative a half on the top? That's what I've got. I don't want that x to the negative a half. You don't need to write negative powers. If you've got a negative power on the numerator, where do you write? Okay. So we keep the 1 up there. The 4 stays down the bottom. I'm only moving the x to the negative half down to the bottom. Okay. Do you get that? I'm only moving that. Don't go moving the 4 and putting negatives with it. It's just this x to the minus half is moving down here. Now, isn't that 1 over 4? How can I write x to the half in a nice way? Square root of x. Now, I've differentiated. It's in a nice format. Find the gradient of the tangent at 4, 1. So I substitute the x value.
Miss, do you have to do that, or can you just substitute in the 4?
You can do that, but I want you. What's wrong?
What's the point of getting rid of the square root of the start if we end up with a square root?
Because you don't know the rule for differentiating root x. There's no rule. It's got to be done as x to the power of something.
Yeah, I thought we were just trying to get rid of it altogether.
No. We're writing root x. When you differentiate, you need x to the power of n.
I thought we didn't want the x at the bottom.
It doesn't. No, that's when you're differentiating, you don't want the x at the bottom. But for substitution purposes, once you've got f dashed x, it doesn't matter. It's just that if you saw x to the minus a half, doesn't over root x make more sense to you? Because we're going to substitute now. So we don't want the root any x's on the bottom for the original function, but once it's differentiated, you make it look like something normal that you like to look at. All right? But the purpose of writing it like this is so that you can differentiate it. So it needs to be in the format of x to the power of n before you can differentiate it. Once you've differentiated, make it look the way you'd like it to look. So substituting x equals 4, you get f dashed 4, I'm going to write, is 1 over 4 root 4, which is 1 over 4 times 2, which is 1/8. So therefore, the gradient of the tangent at the point 4, 1 is 1/8. So do you know, then you would find the equation of the tangent if you had to, using the point gradient formula. All right? So the only reason we change the way that it looks at the beginning is to get it into x to the power of n format. Once you've differentiated it, you put it into a format that you like, that you recognise and can work with. I mean, you can put the 4 up here straight away if you want and do it on your calculator. But I prefer, girls, girls, don't go the short way here. You need to start getting confident and used to that's x to the half, because if you're asked a question with no values and asked to show, if you're asked just to differentiate this, listen, and I put it in one of my videos, if you're asked to differentiate that, I need you to listen carefully. You have to put it in the format down the bottom. Why? Did anyone listen to my videos? Why do you not want to leave the answer like? So if you've got, that's right, it needs to be in the same format as the question. So if the question's given to you as function of x is root x on 2, I don't want the answer as x to the negative a half over 4. They don't want the answer like that. You're not going to get full marks. I don't want the answer like this row either. I don't want it as 1 over 4x to the half. It needs to be in this format because the question is in that format. So the answer needs to be in the same format as the question, otherwise you're going to lose a mark, okay? All right. All right, which other questions, girls?
Did you do question 15?
No,
Can you do it?
I don't know, one sec. Size 8.7, question 15. It says the hyperbola y equals 2 over x has two tangents with gradient negative 2 over 25. I've just done a quick sketch of the hyperbola. It would be in quadrants 1 and 3. It's the blue graphs here, that one and that one. And if you've got two tangents with negative gradients, and they're both the gradients are the same, those gradients would be parallel. So I'm just doing a quick sketch in red of those tangents to the parabola, what it could be. So you have to find the coordinates of the points of contact of these parabolas, of these tangents, sorry. What are you going to do? Gradient of tangent. You differentiate. So you start with the function and you have y equals 2 over x. That's not, we can't differentiate it when it looks like that. I need x to the power, x to the power of negative 1 is how you need to write it first. So you cannot start unless the x, we don't differentiate anything with x's on the denominator, okay? Needs to be x to the power of something. So we go dy dx is, the constant's there, 2 times. Bring the negative 1 down,
Negative 2.
x, and drop this power by 1 and we get negative 2. So multiplying, we get negative 2, x to the negative 2. And how do you write that nicely? Negative 2 and put the x squared on the bottom. Now the only reason we do that is so that we can substitute nicely. Makes substitution a lot better. So now, it says there are two tangents and the gradients are negative 2 on 25. So in other words, dy dx is negative 2 over 25. Do you get that? You don't substitute x is negative 2 on 25. The gradients of the tangents are negative 2 over 25. So you substitute, so the dy dx is negative 2 over 25. So I go negative 2 over 25 is equal to negative 2 over x squared. No, you don't need to cross multiply because you know why? Normally you would, but the numerators are the same.
Yeah.
So the denominators, you don't even need to flip. The numerators are the same, so the denominators, if this equals that and the numerators are the same, wouldn't the denominators have to be the same?
Yeah.
So therefore x squared is 25, which means that x is plus or minus 5. So this is 5 something and this is minus 5 something. Got the idea? So we're going to substitute x is plus or minus 5 into y equals 2 on x. So when x is positive 5, what's y?
2/5.
Yep. And when x is negative 5, y is 2 over negative 5 or negative 2/5. So your points are 5 2/5, negative 5, negative 2/5. Got it? Just be very careful because, so I've just put those points on the graph. Be careful because are they giving you the x value to substitute or are they giving you the dy dx? They've told you that the gradient of the tangent is that. So they're telling you, that the gradient of the tangent is negative 2 on 25. They're not telling you to substitute x is negative 2 on 25. Do you get it? Gradient of tangent is dy dx. Okay. Some people had problems with 8.6. I'll just put that up. I'll just move that over here 1 sec. Which questions? We might be okay with it now that we've done some of these others. We'll just see. Oh, well, it's the last one, yeah. You got all that, girls? We ready to go? Can I move this? Question 15. A function of x equals 2x squared minus 8x plus 3, has a tangent parallel to that line, 4x minus 2y plus 1 equals 0 at point P. So it's telling you when the tangent is parallel to this line, tell me about parallel lines, have the same gradient. So it's actually telling you the gradient of the tangent, if you can work out the gradient of this line. If your tangent is parallel to this line, then your tangent has the same gradient as that line. Does that make sense? So the tangent has the same gradient as the line. 4x minus 2y plus 1 equals 0. Does that make sense to you? That the gradient of your tangent, so the tangent has a, girls, parallel lines have the same gradient. So the tangent has the same gradient as that line. What would you do now? Find the gradient of the line. Y equals mx plus b. Take the minus 2y to the other side, but I'm going to leave it on this side. 2y is 4x plus 1. So what's y? Dividing everything by 2. 2x. So I'm divide everything by 2. So divide this by 2, that by 2, that by 2. You get y is that plus a half. So what's the gradient of your line? So the gradient of the tangent is going to be 2 because it's the same as the gradient of the line. So gradient of the tangent, are they giving you an x value or are they giving you a dy dx? So that equals dy dx. Or it actually, in this notation, it equals f dash dx. All right? So now what would you do? Find f dash x. F, I'm going to do it just straight down here. F dash x, can you see function of x up there? Well, no, all right. I'll just write what function of x is. This is function of x. So f dashed x is 2 times 2x, which is 4x, minus 8 plus 0. So therefore, what do I do now? Substitute f dashed x is 2. So you get 2. Do you get it now, girls? So f dashed x is 2. So you go 2 equals 4x minus 8. Let's not guess. 4x is 10. X is 10 over 4, which is 2.5. Isn't it? Yeah. So the question is, find the equation of the tangent at P. Well, we've got a bit more work to do. This is just your x value. Yeah, you need to find the y value. So we've got the gradient of the tangent. Actually, we already had the gradient of the tangent. We're finding the point where the gradient of the tangent is 2. Look, girls, I'm going to do a quick sketch. That parabola is 2x squared minus 8x plus 3. It's got a y-intercept of 3. We're not going to factorise it. Tell me where the axis, is it concave up or not? Where's the axis of symmetry? Minus b on 2a. Minus negative 8. So it's at 4? No, it's not. Minus negative 8. Minus b. So over, yeah, it's at positive 2. Axis of symmetry is negative b. So it's negative 8 over 2 times 2. So it's at 2. When x is 2, just give me a rough y value. Is it positive or negative? 2. You get 8. It's negative. It's down here somewhere. All right? That's what your parabola looks like. I'm just trying to get you to... And the gradient of the tangent is 2 when it's 2.5. Well, we knew that was 2. So here's your tangent somewhere here. See, we got that the gradient of the tangent was 2 at the point x is 2.5. So you know that this point is 2.5 something. This is what the question means. So you know that the gradient of the tangent was 2. This is roughly what the parabola looks like. I'm just trying to help you visualize what the question's about. All right? I think it might help if you sort of can understand what it's about. So we know that the gradient of the tangent's 2, which happens to be positive, when x is 2.5. What do I need to know? What other value there? Y. So I substitute x is 2.5 into what? Into the equation of the line. Into fx. So I get, and I can just write y equals, it doesn't matter. Do you know what I mean? I'm just going to go, I'll go function of x or y, I don't care. Y is 2 times 2.5 squared minus 8 times 2.5 plus 3. It is just the y value. Do you know what I mean? I can't work that out. You get 12.5? No, it's got to be negative something. Yeah. Negative 4.5 is the answer.
Oh no, I'm talking about the two.
All right. I just want the answer. Is it negative? Negative, girls, stop. It's negative 4.5 if I put it on my diagram. So we've got negative 2.5, negative 4.5. I know the gradient of the tangent and I know the point on the tangent. What do I do now? So my point is 2.5, 4.5, negative 4.5, sorry. Can you write that as?
Then is it just going great for questions?
Yep. Now, let's keep going. So, the point is, so girls, we've got the point is, sorry, it's a bit messy. So we've got that the point is 2.5, negative 4.5, and that the gradient is 2. So therefore, the equation of the tangent. Are we okay? Y minus y1 is mx minus x1. Y minus negative 4.5 is plus, is 2x minus 2.5. Y plus 4.5 is 2x minus 5. And in AX, in general form, keep the x positive. We get 2x, what? Minus y, you're bringing it over. Keep the 2x here. Because minus y, bring the minus 4.5. That's got to be minus 4.5. Yeah. So we've got 2x minus y. Girls, we're keeping the 2x here, so these two have to come over. So it's minus y and minus 4.5 coming over is 0. Now, if, girls, 9.5, girls, the answer may not be written like that. It may be written like this. 9.5 is 19 on 2. How do you think the answer is going to be written?
Just x minus y. Yes.
What should I do with this 2? Multiply through by 2. I reckon the answer in the back would be 4x minus 2y minus 19 is 0. You're multiplying through by 2. You don't leave it as... So girls, if they want it in general form, you're not allowed to have 9.5. Got it? That A, B and C are supposed to be integers, not well, it is an integer, but I think whole numbers. So you may not see the answer like this. It'll be written like this, which is why, girls, can we just, you know, when you do that question up there, I wouldn't do it like that. I would go like this. Y plus 9 over 2 equals 2 bracket x minus 5 over 2. And that way, you're going to know to get rid of, don't do it as 4.5 and 2.5. So we go y plus 9 on 2, expanding, is 2x minus what? 2 times that, 2 times 5 on 2 is what? Negative 10 on 2. Girls, what's 10 on 2? Girls, 2x and 2 times 5 on 2, the 2's would cancel. So then you'd go y, whatever you've got. And then if you're putting it in general form, you go 2x minus y minus 5 minus 9 on 2. Anyway, you still got to get rid of that 2, all right? And you multiply through by 2. So I'd actually probably multiply through by 2 at this point. Do you know what I mean? I'd go 2y plus 9 is 4x minus 10 here. Multiply through by 2 and then take everything over. 4x minus 2y minus 19. Okay, girls? Either way, if you're doing, ladies, if you're doing general form, you don't want decimals. You don't want fractions. Everything's got to be whole numbers. Maybe. Probably. Maybe. I don't know. Depending on